systems architecture or smart role cloud application and service IoT system. I'm Dr. William S. Chow. Chapter 1. What is smart role IoT system? Smart roles are some of the different proposed terms for incorporating sensor technology into the city role development to improve the operation of autonomous cars, to enumerate and monitor road conditions. Behavior of smart road IoT system consists of the following 5 behaviors. The first behavior is sensing traffic conditions. Smart road IoT system deals with sensing traffic at interactions and road accident detection, as shown in Figure 1-3. The second behavior is recording occurring accident. On a road, accidents occur all the time. Once an accident occurs, a policeman will record it on the smart road IoT system, as shown in Figure 1-4. The third behavior is inquiring, warning, and detouring messaging. Smart road IoT system offers natural interactivity over a map of the city road, allowing each driver use his own personal mobile device to inspect those nearby warning and detouring messages based on the driver's current location, as shown in Figure 1-5. The fourth behavior is recording accident response starting time. Once the accident response has been started, a policeman should record it on the IoT system, as shown in Figure 1-6. The last behavior is recording accident response end time. Once the accident response has been completed, a policeman should record it on the smart road IoT system, as shown in Figure 1-7. Chapter 2. What is SBC architecture? In general, a system is very complex that includes many views. There are 2 different ways to model such many views. The first one called the model multiplicity approach, such as UML, will separately pick a model for each view, as shown in Figure 2-5. UML model multiplicity approach will generally allow the inconsistency among these multiple models. The second approach is called the model singularity approach. Instead of choosing many inconsistent models, this second approach will use only one integrated model, as shown in Figure 2-6. Structural behavior correlations, SBC, means to integrate the system structure and system behaviors. SBC architecture uses 6 fundamental diagrams to describe an integrated system. SBC architecture is a model singularity approach, as shown in Figure 2-27. Chapter 6. Framework diagram of smart road IoT system. Framework diagram FD depicts the structural view of a system. As shown in Figure 6-1, There are totally 3 layers for the smart low IoT system. Application layer contains 5 components. Data layer contains 1 database component. Technology layer contains 2 components. Chapter 7. Component Operation Diagram of Smart Low IoT System. Component Operation Diagram (COD) depicts the structural view of a system. As shown in Figure 7-1, there are a lot of components in the smart low IoT system. Also, each operation of the component and their input-output data are all shown in this Figure 7-1. Chapter 10. Interaction flow diagram of smart low IoT system. Interaction flow diagram (IFD) depicts the behavior view of a system. Smart low IoT system include 5 individual behaviors. Figure 10-1 shows an IFD of the sensing traffic condition. In this IFD, we use totally 4 interactions. The first interaction is the server root actor will wake up the traffic condition daemon component. The second interaction is the traffic condition actor will interact with the traffic condition sensor component, and the traffic condition data input will then be output to the traffic condition daemon component. Then the fourth interaction is the traffic condition daemon component will send the traffic condition query input data to the database. Figure 10-2 shows an IFD of the recording occurring accident. In this IFD, there are 2 interactions. The first one is the police actor will interact with occurring accident UI component to input the occurring accident form data. Then the UI component will interact with the database component to input the occurring accident query data. Figure 10-3 shows an IFD of the inquiring, warning, and detouring message behavior. In this IFD, there are 4 interactions. The first interaction is the driver actor interact with the UI component. Then this UI component will interact with the driver GPS component to get the driver GPS coordinate data. The third interaction is the UI component will interact with the database component to get the warning and detouring query output data. The last interaction is the UI component will return the warning and detouring city map data to the driver actor. Figure 10-4 is an IFD of the recording accident response starting time. In this IFD, there are 2 interactions. The fourth one is the police actor will interact with the UI component to input the accident response starting time form data. The second interaction is the UI component will interact with the database component to input the accident response starting time query data. Figure 10-5 shows an IoT OLED recording accident response and time behavior. In this IoT, there are two interactions. The first one is the police actor will interact with the UI component to input the accident response and time form data. The second interaction is the UI component will interact with the database component to input the accident response and time query data. Here, let's have some advertisement. This book actually is on sale on the Amazon website. The URL address is shown on this page. If you like this lecture and want to know more about the detail, you can go to the Amazon bookstore to buy this book. The name of this book is System Architecture of Smart Low Cloud Application and Service IoT System, written by me, Dr. William S. Chow. Thus, thank you for your listening. I'm Dr. William S. Chow. My email is architecturechow@gmail.com. Also, you like to go to our SBC Architecture official website to know more about the SBC architecture. Thank you. Bye-bye.